This talk is all about Gradle. And what's that? I got a heckler. It's like I'm like 20 seconds in. I got a heckler.
There you go.
So, first a little bit about me. Groovy Rails developer at Carnegie Mellon. I've written a couple Gradle plugins too, and I'll show those a little bit later. But there's my website, my Twitter handle, and Groovy Pittsburgh Twitter handle. All right, so I guess first we'll talk about what Gradle is. So it is a powerful build tool with all these features. So Groovy, the Groovy DSL, if you look at the build scripts, they're actually just Groovy scripts, and I'm gonna step back and do a little bit of review of kind of some of the Groovy concepts, and you can kind of see why it's such a powerful language to use for this. It has dependency management. You can use kind of Maven dependencies, Ivy dependencies out of the box. Has support for a lot of languages and platforms through plugins. So I know Android Studio kind of uses that by default. So it's kind of the preferred build tool for Android. They have you can build C++ projects. Java's the big one. I think it's kind of its central use case, and it works really well for that and for Groovy too. And so I mentioned kind of the plugins. There's, we're going to go into a little bit of how you can make your own plugin. But there are a lot of really useful plugins that you can kind of pull into your project, and they'll give you. So you can write these very, very concise build scripts, just by including these plugins, and they give you like a ton of functionality, and we'll see a little bit of that too. And terrible website, awesome tool, awful website. I think you need to see this. So that's horrible. It's colors, man, but no, it's a very cool. Very, very cool tool. I think before I get into this, has anybody kind of played with Gradle at all, or seen a Gradle build? Like very basic. Yeah, because I'm wondering if I should kind of dig into kind of an example first. So since we got some Java folks in here, kind of. So this is it for a Java application. Oh, is it small? Okay, is that better? I thought you were talking about, there's only 3 lines of code. Yeah, Bill, this is no surprise to you. But, yeah, and if we kind of take a look at what we get by applying this Java plugin and this application plugin. I get a run task as part of the application, and if you look at the code, it's just like a very simple kind of hello world or hello Java. But and it sort of follows. If you look at the kind of directory structure there, it's kind of following the Maven conventions. Everything kind of in source main Java. And So, you know, and the only thing that we're really specifying here is just the main class, like where to, uh, and we get all kinds of tasks. You could build a jar from this. Um, so it doesn't, I mean, you kind of compare this to a comparable Maven file. I think there's kind of no comparison. I mean, it's very powerful. And they give you so, and I think it's like pretty common within the Groovy ecosystem. You kind of get this idea of convention over configuration. So if you're kind of using the defaults, you're using kind of the standard Maven project layout, you know, your build script is super tiny. You know, you're just applying those plugins, you're just setting that main class. But you know, you can kind of override everything too. And like you can extend and you can add more plugins and you can write your own tasks. And so I kind of wanted to sort of, before I dig into the Groovy a little bit, show everyone kind of what a really basic Gradle script looks like. And this is a recap, I guess, of some of the stuff we've already talked about here, but it's kind of important just because I really want to get the point across that that build.gradle file we were looking at. I mean, it's not like a config file. I mean, it's code, and anything you can do kind of within a Java class, you can do in that script. So, I mean, it's just Groovy. It's a Groovy script. And kind of understanding some of the Groovy syntax like helps you kind of take a look at that and see. So then we'll kind of go through the fundamentals, maybe look back at that script and you can kind of see exactly what's going on. So, you know, Groovy itself is a language, and I think these are some things that make it really well suited as a language for Gradle. Is the syntax is very simple, because you can imagine if you're writing kind of a build script in Java, it's got to have a class, it's got to have this like static, you know, main, and there's all this kind of ceremony, and your build kind of gets what your build is actually doing kind of gets lost in all that. So Groovy's, you know, the syntax is, it's Java, but it's with a very, very pared down kind of syntax. You know, some features like operator overloading, scripting support, and really that kind of that build.gradle is just a Groovy script. And metaprogramming, and we'll see kind of why as we look into some of the more advanced plugins that you can develop. Actually, we're just going to kind of touch on it a little bit. Build a simple plugin, and then you can see where kind of the meta, that sort of dynamic metaprogramming stuff comes into play. So first, and this is kind of for, you know, I guess for some of you maybe from a Java background, this is kind of the syntactic sugar you get for you know, defining a map or a list, and you know this, and you have you know things like command chaining and optional parentheses, which make for these kind of nice readable DSLs. So and kind of when you're building out this script, like having this this kind of very readable, I mean, the syntactic sugar ends up really mattering, because when you're trying to look at this build file and kind of understand what's going on, you don't want to have to, you know, create a new instance of hash map and like have to worry about the kind of specific types of everything and add each element. I mean, like you want to be able to just kind of put a list of, I mean, if you want a list of strings, you want to be able to define it like that. And operator overloading, which is something a lot of the DSLs you can use within Gradle used quite a bit. So you can kind of override any of these operators. And each of these plugins that you might apply to your project usually kind of introduces its own kind of mini DSL that uses Groovy. And this is kind of one of the tools that a lot of them use. And I'm going to just kind of touch on this a little bit. So I'll probably skip this. But closures are important. And they're, you can think of them a lot like, if any, they're a lot like lambdas in Java 8. And so let me see. I think I have an example here. Now, so here I'm actually going to drop down to an example here. So here's so this is a closure right here. So these curly brackets, you know, you can think of it almost like I mean, it's a lot like a lambda, and you'll see this kind of play out a lot in these Groovy DSLs, because using kind of closures within closures, you get this kind of nested structure that's sort of like XML, but obviously a lot more dynamic, because I mean it's an actual programming language. So this is this is just a block of code that you can pass around. It's a first it's a first-class function. You can pass it as an argument. You can assign it to a variable, and you could even return a closure from a function, or return a closure from another closure. I mean, so it's kind of a very functional programming way of dealing with this stuff, and it really comes into play a lot in some of these Gradle DSLs. And the thing that makes these pretty neat too is you can assign kind of the delegate, and I think in my example you can see. So I've defined this closure. Just so it's like just a block of code that's executed, and I have just a regular Java class here, name printer, and by setting the delegate of that, all these methods and variable assignments, they're kind of resolved to this. So when I actually run this, I get my name is Craig Burke, because the name is set up here within the closure, and the print name function is called, but all that happens on the delegate that's assigned, and that's an instance of this name printer class. So
So go ahead. So at that point, does my closure.delegate have access to whatever's in name print? So in other words, if inside of name printer it was public string name or public string foo as an attribute, if I say my closure.delegate.foo, would I have access to the value of that attribute?
No. So and you wouldn't have to. So
I'm just trying to understand the meaning of the delegate.
So the delegate, I mean, I guess that would work, but really you're setting the delegate. So it's kind of this combination of the delegate and the resolve strategy. So so within kind of looking at this like my closure. Print name, it could be, where it goes to resolve this. It could be kind of within this containing object that it's in. It could be, and depending on the strategy, like maybe the strategy is the, kind of an owner first strategy.
So in terms of delegate, it's just a way of associating some arbitrary class with that closure.
Mm-hmm.
Is that right?
Right. Yeah, it could be an instance. It could be.
But it has to have a print name method in it in order for it to be declared to be the delegate.
Well, so and that this is like
Because it's called.
if I had this as delegate only, then absolutely. So delegate first. This is just kind of the the places it's going to check, like kind of the order of where it's going to check. So I assign the delegate and I set the resolve strategy to delegate first. That means anytime there's a property or a method call, it's going to say, okay, well, my resolve strategy is delegate first. First, I'm going to check the delegate to see if this method exists there. Okay, it doesn't. Then I'm going to check kind of the owning class.
So if there was another print name function in this script,
Right. Yeah.
then it would, if I do delegate first, I first look at print name inside of name printer. If print name wasn't there, then I would go to the print name that's in the global declaration. Is that correct?
So in this,
How many possible resolve strategies are there?
I think there are three.
Just delegate first and delegate only?
Well, no, there's, let's see. Did I have this? Shoot. I might have put this, so I have the closure scope. There's only a handful of them. So it's either going to resolve to kind of the, there, and I'll, rather than kind of give you like an answer based on. So if you look at there's like so here so these fields, so there's delegate first, so it checks delegate first, but still kind of falls back to the owner. Delegate only, it only checks a delegate. If it's not in the delegate, then and then owner first and owner only. And I guess there's also a to-self resolve, which I've never actually used, but
And owner is if it's actually in the closure itself.
right. So the owner could be either. So that's a little bit. I mean, the owner can be the class that the closure is defined in, or it could be an outer closure. So if it's like a closure within a closure, the owner is kind of a
And that's the situation in which this and the owner have different.
Yeah, exactly. Yeah, exactly. Yeah. Okay. So. Yeah, cool. Good questions. So, and I guess this is what we were talking about, kind of this idea of closure scope. This and owner are usually the same, but there's that kind of one case where if a closure is declared within another closure, then owner is that outer closure. So, I mean,
An example of a pattern in which you'd have a closure inside another closure.
a lot of DSLs do it, so that you kind of have like these closures within closures, kind of like what I was talking about with that sort of nesting structure, that sort of XML-like structure.
Okay.
So that's kind of one. Primarily it would be in kind of these DSLs. I don't.
So this and owner are these things that are automatic. What if you have? What if it's 3 or 4 levels deep? Then where's owner at the top? The next one?
I think it's the parent closure.
It's the very top.
No,
Oh,
it's
it's the one
the immediate.
It's
Yeah,
the
it's the
immediate
immediate parent. Yeah.
And you don't have access to stuff in the closures further up than that in the hierarchy.
I mean, I guess you could do owner.
Owner of, yeah.
I mean, but and really the delegate is the only thing that you can reassign. So these are, I mean, you can kind of look at, obviously you can look at this or you can look at owner, but you can't reassign them. Those are static. But delegate can be, whatever you want. I mean, it could be some random class. It can be, really anything. So, and here's another thing. Getters and setters. This is just kind of another example of syntactic sugar that you get. So you have, pogo, like a pojo, and with this person class, it kind of behind the scenes automatically generates a set name and a get name method. So instead of, so it's nice and actually like writing these classes, but you see here where you're setting it, like you set it like a property, but this ends up kind of resolving to person.setName Craig. So you see this is kind of like, this is equivalent. So you can within Groovy, you could even, you can use a Java class that has these setters and getters and kind of write them as like this property access in this property access syntax, which is very nice. And sort of this last example here is kind of a, so you can see, I mean, obviously within a build script, within kind of this DSL, writing something like this is a lot more kind of preferable than writing something like this.
This would be kind of, maybe I don't understand. What if you have public attributes where you can actually access them that way in Java without using individual setters?
So that'll still work.
Oh, okay, all right.
Yeah, I mean, but if it does have a setter and a getter, like this will kind of, it'll resolve to that. And this is where things get very crazy here with the dynamic properties too. So I kind of breezed over this meta class thing. So any instance of an object or any class has within Groovy a meta class, so that you can kind of hang, you can override methods, you can hang kind of these. And here I'm using this for an example. This get dollars method that I'm just hanging off the number class. So like any arbitrary, an int, a float, anything. Since I'm, dealing with money, I cast that to a big decimal so that a type that's more appropriate for that. And this, obviously you wouldn't want to like hard code exchange rates within a method of, because I think, well, this is probably like way off because I think I grabbed this example like 6 months ago, so I'm sure these rates are like totally wrong, but this kind of gives you an idea. So I have this kind of get property. So I see down here, there's I'm doing 40.euros. So kind of first checks to see, is there a get euros method on, kind of either on that integer class. Well, no. So then it kind of drops down to this generic kind of get property method. So that's what it ultimately resolves to. So that both .euros and .pesos, which are equivalent to get euros and get pesos, resolve to this. And then it does the kind of conversion from dollars or euros to dollars and pesos to dollars. So then I can kind of add them all up together, and this is kind of a reasonable. It's kind of a not like a real world example, but just kind of a neat. Kind of show you how dynamic.
Sorry, Craig, could you just go back?
Sure. Sure.
And I apologize if I'm bogging this down, but
No,
where does the math actually happen?
So this kind of, so I think I have this. All right, so, okay, so right here. So if I kind of rewrite this as,
Okay.
so,
Yeah,
yeah, and that's kind of doing that mental translation. Sometimes you're thinking Java and like kind of looking at Groovy. It takes a little bit, but I mean, kind of once you get past that, it's you never want to go back. So yeah, the dynamic methods. You know, so similarly, like with the kind of I don't know. I've heard this called like kind of pretended methods or pretended properties. So this dynamic methods. So it's a really simple class here that I've defined. The only thing I have is this method missing. So that any method it can't find will drop down to here. So then I get access to the name and the arguments that I pass to that. And you see down here I call this say hello method. And since it starts with say, then it just prints out the message. So I'll show that real quick. So
So correct me if I'm wrong, but you could essentially write a DSL using primarily missing correct.
yeah, absolutely. I mean,
I know there's other ways to do it, but you could just use that if you want to get yourself started.
yeah, and kind of assigning delegates, and you could do it you could do like a real quick and dirty DSL like that, and obviously that method missing is going to get enormous. Like, and so then you got to kind of use other you know, kind of like a builder pattern or something. But yeah, you're absolutely right. Okay, so I was planning on breezing through that, but that's okay. I mean, it's cool. We got a lot of good questions. So we'll actually get to the Gradle part of this. Yeah, I mean, it was like, you know, I guess it wasn't like totally unrelated or anything like that. Like this is. I mean, it's important. It is kind of when you, and I think once you get comfortable with the idea that build.gradle file is just a Groovy script, then kind of the possibilities like really open up in terms of what you can do. So first, kind of some base terminology for Gradle. And this is, I think this is kind of self-explanatory, but just so you know what I'm talking about when I start saying these things. You know, a task is just you know, like a little chunk of work. And, you know, you kind of have, tasks have dependencies and there's an order to tasks. And that all happens within the context of a project, which is kind of a collection of all these tasks. And a build, and I don't really talk about multi-project builds, but Gradle has really nice support for that. A build is just kind of a collection of projects. So we're really going to be talking about mostly tasks and projects. So, no, you guys don't have Wi-Fi, but I'll put these slides up. If you guys are using Mac or Linux, I would definitely recommend using SDKman to install Gradle. The alternative is you can go to just gradle.org. Try not to look at the blinding colors, but or you can use if you're just kind of pulling down a project that's already using Gradle. Most of the time it'll have this Gradle wrapper, so you don't even have to have, I don't know if you guys are familiar kind of with like the Maven wrapper or something like that. I mean, it's kind of the same thing. Like you don't have to have Gradle installed locally. There's a Gradle W file there, and all the examples I have here have the Gradle wrapper, so you can just, when I post it, you can pull it down and start playing with it without actually having to install Gradle on your machines. So in terms of creating, a new Gradle project, really all you need to do is just create a build.gradle file, and that's it. Then you start adding your plugins, defining your tasks within that. There's also this Gradle init task, which is pretty nice. So if you have Gradle on your system, it'll create a project. It'll add a Gradle properties file where you put kind of settings for your build. A build.gradle with some kind of guiding comments, and the Gradle wrapper. So kind of everything you need to get started. So we'll start talking about kind of that first basic unit of work, the task in Gradle. So this is how you define a task. And you see, and kind of remembering back to what we looked at with Groovy, I mean, this is a closure. And you got to think about kind of the optional parenthesis here. Let's see. I'll just do a new. So when you see something like this, you kind of translate it in your head to, okay, within this closure, there's a do last method. I'll make this a little bigger. You strip away those, like, since you're stripping away the parenthesis, it's hard to, like, you're kind of, I mentally have to do this sometimes just to kind of understand what's going on. Really what's happening here is this do last method is called, and a closure is passed as the only argument.
Do you need to have the hidden context display?
Oh, is that distracting?
Okay.
Is that better? Be cool. I like it because I need to. If I see a tab.
Consistent with indenting and stuff.
What's that?
So you can be consistent with indenting.
Yeah, I mean,
It
usually.
helps with text mate, actually.
Yeah, with text mate, because if I see a tab,
That would be good. I've been yelling
But usually, I mean, if I use, I usually TextMate I'll use if I'm just like kind of screwing around with something, or for presentations, just because less moving parts to explode during the presentation. But usually, IntelliJ is pretty nice, and like kind of its auto formatting is awesome.
Tabs are much better.
Yeah. So. Actually, that's so. It's all just code. I mean, this is just. So this defines a simple task that just prints "Hello World" out. I think I have this. Okay, so tasks. So this, you see with the Gradle W command, I'm using the Gradle wrapper here. Y'all see that? And tasks just gives you a list of all the tasks for that particular project. A lot of these tasks are just part of every project, kind of part of the Gradle core. But this is a task that I've defined called foobar. And if I
Sorry, what exactly is the wrapper?
So a wrapper is an executable that will basically run Gradle without you having to have Gradle installed on your system in your path. So it's just it's something that you can add to your project, actually commit to the repo, and then it's really helpful for stuff like continuous integration. So it's part of the project. It can just run it. Your CI server doesn't have to worry about how do I install Gradle.
Okay.
So it's kind of
If I
serves
could
that
add to
purpose.
that too, it also helps with, so when you add your wrapper, it makes whatever the executable script is on that, it also brings a .bat file. So that's basically what it does is, especially when you're using Windows, it brings a .bat file that is good, so it would really run from there. So you don't need to tell, if you're going to distribute something to a colleague or something, you don't need to download Gradle. It'll download itself. So
And
that's the
And it's a specific version of Gradle too. So that's, so you don't run into issues like maybe on your machine you have an incompatible version of Gradle installed or something like that. You have kind of a known good version of Gradle that you're using on this project. So just run the wrapper and you know that particular version of
And,
Gradle is going to
and
run.
almost all projects that are built with Gradle will come with a wrapper.
Yeah.
will you have to, like if you're creating your own project for like text maybe, yeah, you have to run the command. What is it? It's just
So there's,
Gradle.
yeah, so there are these two, you see up top, these two commands, like the init, which I talked about, kind of creating that. And there's also just the wrapper, which creates those wrapper files for you. And you can pass it,
Yeah, so I just did an init and I got a wrapper.
yeah, exactly. Yeah, so the init does everything. It does kind of like the full project structure, the build-out Gradle, the settings file, plus the wrapper. The wrapper just does the wrapper. So, yeah, no problem. Okay, get out of this. All right, so kind of looking at this. So you see just two simple tasks that I defined, foo, bar, and this task, which I'm really just using to kind of bring those dependencies together. So, and you'll notice when I did that, ran that Gradle tasks, because it's those other tasks are just dependencies of this foobar task. Foobar is all that's listed because it's kind of like it's like a top level task. And if you wanted to see, and that Q is just kind of the quiet setting, so you don't see a bunch of
It's one.
that -Q setting that I'm using is the quiet setting, so it doesn't makes the output a little simpler, so a little less confusing. --. So, and you see under foo bar, you have the bar and the foo tasks that I've also defined. So, kind of see it all, and they can be run independently. So bar just calls the bar task. If I call foo bar, it calls bar then foo. Actually, I'll run that with quiet to make it a little. And this is something that is kind of tripped me up a little bit when I was first starting to. Because if you look at this, you might assume, and I think it's not an unreasonable assumption, that by declaring it like this, that it's going to respect that order, that it's going to run the foo task then the bar task, but it doesn't. So, and there are ways to kind of specify that ordering, but that's something to keep in mind. So if foo has to run before bar, obviously an easy way would be to kind of just change the dependency here. So then this way, Gradle's going to look at this and then realize, okay, well, bar depends on foo. I have this list of tasks, therefore I have to run foo first and then bar. So then that's kind of one way to enforce that order. So then you see this time foo ran first, then bar. So, and another thing, and this is kind of something else that, and I'm trying to show some of the pitfalls, I guess, or some of the things that confused me at first when I was writing Gradle scripts. Task phase. So there are kind of two phases as Gradle runs. And each task you can kind of define, use a closure to define like what happens within each of these phases. So there's a configuration phase, and the configuration kind of block for every single task is run every time you run Gradle. So even if you just run Gradle tasks, it'll run the configuration block for every task. So it's important if you don't want a task to run, and the different, that's very different than the execution phase, which does, kind of the actual work that your task, you want your task to do. And obviously, you don't want to make the mistake, which I have, just because the syntax is can be a little confusing. You don't want to make the mistake of doing the actual work within the configuration phase, because otherwise it always runs. So here's kind of an example here. So right here, the thing within this, so that main closure, that kind of parent closure, is the configuration phase. And I'm calling this do last on setting what's going to run in the execution phase. This is, I had an example of this.
That do last close method, is that convention that its name is do last, or that's a keyword?
It's a method. So there's a
Right, but it has to have the specific name of do last.
yeah. So there's a do last and a do first. And, okay. All right. So actually, this is the one I wanted to show. So, and this is some groovy. Bill's gonna yell at me. I got the hidden characters shown. Sorry, Bill. So, and this kind of shows the distinction here between do first and do last. And I think this might seem a little strange. This syntax, the 5 times. I mean, I think it's just running this block of code 5 times. So I've defined a task, and I'm kind of I'm calling both do first and do last 5 times. And you'll see kind of shows the difference here between the two. So with do first, it's you see it kind of counting down, because it keeps adding it to the very beginning of the action list, whereas the do last adds it to the very end. So you see kind of do first counting down and do last counting up. Okay, so and this is, when I first started, I used this alternate syntax, and you'll see this quite a bit in the Gradle documentation. I would recommend not using it, because this is extremely confusing, I think. So this using some operator overloading here, the kind of double arrow thing here, to say, okay, this is the execution phase, and that's okay if you're only kind of declaring that execution phase. So this is an alternate way to write that do last. But you see down here, if you want to do kind of the configuration and the execution, it gets a little bit messy. And it makes it like a lot easier to make the mistake of defining something as a configuration block, like forgetting to put the double arrow and having like your action run every time Gradle runs, which is not what you want, because it's so easy to miss that. I think it's just better to kind of go to use this do last. So you're kind of being explicit. There's always a configuration block, and optionally you're defining an execution block too with it. So, and these are, I kind of talked about the issue you run into, that you can't assume that tasks will run in the order that you kind of declare them, because Gradle's gonna do that configuration phase, and it's gonna come up with its own plan if you're not kind of really explicit about this is a dependency of this. So it's just going to kind of use those direct dependencies and saying, well, maybe I'll run this in parallel. Maybe I'll run, maybe I'll run this before that. And, so it kind of makes up its mind unless you use kind of these keywords. It depends on, which we saw, kind of creates that direct dependency. Finalized by is something that's handy if you want a task to run after a task, even if it fails. So this would be kind of like, you can think of it kind of like the finally block in a try-catch. So should run after and must run after. This is kind of another way. If we go back to, and I think should is kind of less of a command and more of a suggestion, and must is it's like maybe if you wouldn't mind running this before, but it can still do its own. Like it can still run them in parallel. It could still. So if I go back to that, so go back to this example. So I could do something like this, which is like, I don't know. I guess just doing a depends on. Well, no, that's not. So here's the distinction here. I guess I should step back. So it's not. So the depends on means that every time you run this task, that dependent task must run. And it's like a little bit slightly confusing. This must run after only runs if you're kind of already running the food task. So it's not, you can run the bar task by itself and it doesn't necessarily run the food task. But if it was a dependency, it would run the food task always when you run the bar task, if that makes sense. Or if what I'm saying makes sense. I don't know that it makes sense, but so. All right, so and I kind of looked at this a little bit at the start here. Is this idea of these plugins, using these, and these are core plugins that are just part of Gradle, the Groovy plugin, the Java plugin, and there's a whole. There's actually a lot of really useful plugins. There's a kind of a Maven publishing plugin that lets you, kind of really easily publish, an artifact that you're generating to a Maven repository. There's a lot of really handy plugins that are like just part of Gradle itself. And we didn't really look at the tasks for this. And so so if we look at so we'll start with the simple Java. simple Java project. You kind of see the tasks that this gets us. This build task, so they're kind of like two main tasks. So there's kind of assemble, which kind of compiles it and kind of creates whatever artifact, like your jar file or whatever. And then there's the check task, which runs all your tasks, runs any other validation. Maybe there's some code analysis tool that you're using. So that would be attached to that task. And then this build task is kind of the main task that brings it all together. So it depends. It depends on assemble and check. So first it checks everything out, and then checks, verifies that everything's the tests all pass and the code matches whatever maybe conventions you have, and then it does the actually assembles the artifact. Let's see. And dependencies. So this is, and I'm kind of showing two different syntaxes here. So, and I'll talk about this a little bit. So just looking at the simple build file, these methods that I'm calling are kind of predefined repositories that are kind of shipped with Gradle. You can add your own Maven repository as a source. You can add a file system folder if you have like a folder of jars as a repository. And the dependencies down here are it kind of goes looks at these repositories in order and tries to resolve these dependencies and these dependencies. So Maven local, if you have it already installed. If not, it kind of drops down to Maven Central. Okay, Maven Central doesn't have it. Maybe JCenter, so it kind of does all that. And we have two dependencies, each in a different kind of configuration. So, and this is part of the kind of Java and Groovy plugin. They give you these kind of out of the box, these dependency configurations. And it's just kind of for building like a class path for, these are kind of self-explanatory.
The order in the repositories is maintained?
Yeah, I believe so. Yeah, I believe so. And so this, and I think this kind of makes sense to everybody here, kind of this idea that there's, you kind of have these compile dependencies, you have these runtime dependencies. And it's just kind of, by using that DSL up here, we're kind of helping to build the class path for these different contexts. And this test compile, this Spock, that's the testing framework. So we don't want to package that with our kind of final artifact, but we absolutely need it to compile our tests so that we can actually run them. So and you can actually make your own. You can add to these, make your own kind of configuration. So it's just a collection of dependencies. So, and this is where things get very, very crazy. In a good way, at least I think. So custom plugins. You have a couple options here. You can, you can call apply from a file, and basically it's almost like an include. So if you want to define a bunch of tasks in another .gradle file. You could just include that file, and it kind of brings it into that. And that's, I don't know if I call that a plugin, but I kind of added it on the list. And there's also a special directory called build source here. And if there's and what's in build source is actually a totally separate Gradle project that gets compiled and added to Gradle's class path before. Yeah, this sounds insane. I'm gonna show you an example. So first, it's kind of important to notice. I mean, we're talking about kind of building these, using these dependency configurations. So the class path that Gradle uses to actually run is not the same as the kind of your application class path. So Gradle plugins have to be added within kind of this build script. So this is an example of a third-party plugin that somebody published. It's actually a really nice plugin to create fat jars. And but in order for Gradle to use it and apply this plugin, it has to be added to its class path up here. But if you were to make kind of a plugin project, and I'll show kind of an example of that within build source, it automatically kind of gets added to this build script class path. So it's kind of smart enough to realize, okay, there's a build source folder with a plugin project here. I'm going to compile that, use that code in my class path, so then you can apply any plugin you might define there. So let's see. So here's kind of the like a very, very simple plugin I've called just food plugin. So can you see the, I guess I can't make the folders bigger. So I have this build source directory. Can y'all see that? All right, and you see kind of the standard source main Groovy. And what I have here is a class that implements this plugin interface. And and here's kind of another concept, this idea of an extension. So you're kind of seeing through these build scripts like this thing a lot, like you saw dependencies and then a closure, and then something repositories and a closure. So you can define your own extensions like that, and that's what I did here with I made a foo extension, and all it is a simple class with a message property. And so my plugin adds that extension to the project, and then creates this just a show message task that just prints it out. So not really useful, but it this is just a bare bones. And the only other piece of this is this properties file. So you just have to kind of point it to kind of the name of my plugin, foo plugin.properties within the meta INF Gradle plugins. And so I can point it to my plugin class, my implementation class. So like when I apply this plugin, use this class. So, and that's this foo plugin class right here. So, and so if we look, it's added my tasks by my show message task. I applied the plugin, and it used my message, or it will Getting ahead of myself here. Spoiler alert, it's going to use that message. So, I mean, it's like a very, and probably a more interesting example here. I guess a little bit more involved. So the stuff within that build source, I mean, it truly is its own Gradle project. So I have this example here. So my build source here has its own build.gradle file with its own dependencies. So I'm using this git library, which is Java, or actually a Groovy library that lets me interact with Git repositories. So this is a bit more of an involved plugin. We can take a look at the, I mean, the plugin itself is more complicated, but you know, I have like a really, it's kind of a pointless, I shouldn't say pointless, but it's kind of just to give you an example of the kind of things that you could do. So I have this plugin here, and it creates this GitHub extension. Now this is using that method missing thing, that dynamic method. So kind of look back at the build script. Really what's going on within this closure is I'm calling a method called karma. And these are just the names of plugins, my Gradle plugins. So it's really doing that. So that would, and since those, so I can take the name of the method and realize that's kind of like the name of my, you know, kind of what I'm calling this project. And the first argument should be a string that I can kind of split on that dash to get kind of the user in the repo, and then create this a GitHub repo instance here. And then this is the interesting part here. So I'm using the after evaluate hook here to, you know, so this is after it's done the configuration phase, or, you know, kind of done the initial evaluation. And every repo I add, I dynamically add a task. So it added a Bower download task and a Karma download task. And if I built this out, added more repos, it would add more tasks dynamically. So we can let's make the quiet, turn the quiet on. So what it does is it just, you know, clones that Git repository from GitHub, and then puts like the hash of the last commit up on the screen. So just something really, really simple, but a little bit more involved. I mean, you can use any Java libraries, any. And actually the build.gradle itself, it has a lot of So, and this is kind of an example of one of the plugins I did, and I use it. I don't know if any are familiar with Bower. It's kind of use it to install a web client-side dependencies. So, you know, and I have some interesting operator overloading here. So, kind of in this example, I'm downloading and installing like a 1.4 version of Angular, and downloading this another JavaScript dependency, Angular Animate, and moving it to a different folder, and kind of controlling where the files in these repos go. So, but it's just code. And really I could do something like oh good, the invisible characters are turned off. So I could I'll do something like this. Now it works just the same, or, you know, I could even actually I don't need to. This is a little bit more like, not something I'd recommend, obviously, but I mean, you kind of see that you have a lot of these DSLs are not, I guess, as rigid as you would think at first looking at them. I mean, it's ultimately just code.
I definitely agree. I'm sure you've heard me say this a million times. So I kind of struggle with Gradle until I realized that it's just Groovy. And then, once you realize that syntax like how you're just using Groovy to kind of script through Gradle.
Yeah.
Everything comes together. So,
Yeah, so
that's the.
I mean, and that kind of just, it's sort of not scratching the surface. I mean, it's an extremely powerful tool with a terrible website. So here's a list of some resources for anybody that's kind of interested in learning more about it. Those first two books are actually free if you register at Gradle's horrible-looking site. Those are two O'Reilly books, and they're actually really good. This last one, Gradle in Action, is awesome. So, I mean, if you want to get a really good, deep understanding of Gradle, that's probably the book I would grab. But these other two books are free and also very excellent. So I have links to a couple talks too that are pretty good. This one, this From User to Addict, you might be interested in because it was at an Android conference, so he's talking about it from kind of the Android perspective, and so that's a really good talk too, and the Gradle user guide, which is definitely solid. Thank you. It's a party parrot, man.